Want hard GED math practice questions to help you level up with your GED math studying? Then stay tuned. Hi, this is Parker from Test Prep Champions, teaching you how to pass the GED fast. You can get started by clicking subscribe down below. Story time. So this is a true story. I was once working with a student in person. I was tutoring her for GED prep, and I gave her one of these problems, and it was so hard for her that she was so demoralized that she actually wanted to quit for the day after that. And I felt really bad, so after that, I don't usually give these problems out to students without giving them a warning first that, hey, these are hard problems. But if you're up for the challenge and you really want to accelerate your GED progress, then give these problems a try. And I'll put a link to a downloadable PDF version down below for those who want to follow along on the PDF. And also let me know what you think of these questions. Are they too hard? Are they too easy? Are they just right? And which question do you think is the hardest? Let me know down below. Let's get started. Question asks you to find the area of a circle given the circumference. So it says if the circumference of the circle is 10 inches, what is the area? So pause the video and try to do this now. Okay, let's go over how to do this. So first of all, what is the circumference? So the circumference is just a fancy word for the distance around the circle. And the formula for the circumference is C, so C represents circumference, so C equals 2 times pi times r. So what is this symbol pi and what is r? Okay, well pi is just a number. It's a symbol that represents a number, and you just have to remember that it's approximately equal to 3.14 for your test. So pi is approximately 3.14, and I say approximately because there's a bunch of numbers that goes on and on and on, but you just have to remember the first three numbers, the 3.14. All right, so that's what pi is, but oftentimes in math questions on the GED, you can just leave it as this pi symbol. You don't usually need to turn it into a number, but you can. So we have C equals 2 pi r, and so the r stands for the radius. So if we start here at a point on the outside of the circle, go all the way to approximately right into the halfway point of the circle, right? Which my drawing is an approximation, but imagine this line is halfway into the center of the circle. Okay, so this line from the end of the circle to the center of the circle is what we would call the radius, all right? And it's just a distance here. So the distance from a point on the end of the circle to the center is the radius, all right? So now let's also look at the formula for the area of a circle. So A equals pi r squared. So what's the strategy here? Well, the strategy, since we know that the circumference is 10, all right, we've got to take this 10 and plug it in for C. So we're going to replace the C with 10 because we know the circumference is equal to 10. And then we're going to do some algebra here, and we're going to try to figure out what r is. And then once we know what r is, we can then take our area formula here, and we can substitute that known value for r into r in our area equation, and that's going to spit out the area. All right, so here's how you would do it. So again, we said that 10 is going to replace C. So we've got 10 equals 2 pi r. Okay, and so the goal here is to get this r by itself on one side of our equation. We want to solve this equation for r. So what we see here is 10 equals 2 times pi times r. Okay, so the opposite of multiplication is division. So if we want to get rid of the 2 and the pi, we want to divide here, all right? So this will all cancel out, but whatever we do to one side, we also do to the other. So we're now going to also divide by 2 pi over here. So we've got 10 divided by 2 pi is equal to r, because all of this is getting canceled out here, right? So now what we can do is divide by 2 from 10, and that's going to leave us with 5 over pi equals r. Okay, and we're just going to leave pi as this symbol right here. We're not going to write 3.14. There's no reason to right now. So we now figured out that r is 5 over pi. And so now what we're going to do is we're going to take that formula for area, and we're going to substitute r into it. So we know that the area is equal to pi r squared. So we take that r, okay? The r, remember, is 5 over pi, okay? And this is squared, okay? So here's the trick. So what we're going to do here is we have to deal with this exponent first before we do anything else. So to do that, okay, let's treat it as if this is 5 squared and as pi squared. So here's what I mean. So let's say that we were rewriting this as pi times 5 squared divided by pi squared, okay? And so 5 squared is equal to 5 times 5. All right, so we can write the area now as being equal to pi because we keep that little pi out front here. And 5 squared is just 5 times 5. So let me just write that here. 5, okay, 5 times another 5. Now, pi squared is just equal to pi times another pi. So now that we've written it out this way, hopefully you see that we can take one of these pi's here and we can cancel it with this pi up here, because pi divided by a pi is just going to cancel out. So pi divided by pi is just going to be 1. So we essentially have 1 times 5 divided by 5, and we don't need to write that 1. So now we can simplify this as area equals 25 divided by pi. Okay, and so now why is it 25? Well, obviously because 5 times 5 is 25 here. All right, and want to know the units, that's just inches squared. All right, next question. Okay, question number 2. What is the domain and range of the following function? And here we have f of x is equal to x squared plus 8x plus 16 divided by x squared plus 3x minus 4. Pause the video and try to figure this out. Okay, let's go over how to do this. So what is the domain and what is the range? Well, the simplest way to think about it is that the domain is all possible inputs to a function, and the range is all possible outputs. So what do I mean by inputs and what do I mean by outputs? So basically, we can input numbers into this function here. So for example, we could put a 1 into the function. All right, we could use 1 as our input, and in that case, what we would do is all of these x's here, we would then replace those with the number 1. Or if 2 was our input, we would input 2 into the function. So we'd put 2 in for x, and then that would mean that we would substitute all of these x's here into the equation for 2's, and we would solve the question. And whatever number we get as a result is our output. All right, so the domain is all possible inputs and the range is all possible outputs. So how do we go about by finding the domain? Well, usually to find the domain, there's one main concept you have to know, and that's that you cannot divide by 0. Okay, so if you ever put this into a calculator, like for example 5 divided by 0, or any number divided by 0, 15 divided by 0, all right, you're going to get an error on your calculator because you cannot divide by 0. Okay, so one of the main things you need to know for figuring out where a function is undefined, or in other words, which value of x makes the function undefined, is whenever you get a 0 in the denominator. So what we want to do here essentially is we're going to take the denominator of this function here, all right, and the denominator is just everything in the lower portion of the fraction, and the numerator is everything in the upper portion of the fraction. And we want to set this equal to 0, and we want to find which values for x are going to give us a 0 in the denominator. So hopefully you noticed here, if you've been studying for a while, that we have two quadratic equations. Okay, so a quadratic equation is what we have in the top and in the bottom. And so we can solve these quadratic equations by factoring. So we're going to factor both the top and the bottom here. So we're going to get some practice with factoring, and we're also going to find the domain and range. So how do we factor? Well, let's just focus on the top quadratic equation first. So this x squared plus 8x plus 16, let's factor that. So the way that we're going to factor it is we're going to take the number here, okay, the number here, which is like a 1. So there's an imaginary 1 out in front here, in front of this x squared. So we take that 1. So we take the first term and multiply it by the last term. So we would do 1 times 16, which just gives us 16. Okay, so now what we want to do is we want to find two numbers that will multiply together to give us 16, but will add up to give us 8. All right, so what we can do is just list factors of 16. So what are some numbers that we know that will multiply together to give us 16? Well, one pair is 2 and 8, and another pair is 4 and 4. So we want to add these up and see which pair is going to give us 8. So obviously, if we do 4 plus 4, that's going to give us 8. So this is our pair. So when we factor this, okay, what we do is we're just taking the top part of the equation here, all right, and we would then rewrite this x squared plus 8x plus 16, all right, as x plus 4 and as x plus 4 and also x plus 4. All right, we've got x plus 4 and x plus 4. All right, so that the top part of the fraction here is officially factored. So now let's factor the bottom portion here. So this x squared plus 3x minus 4. So again, let's take the first number that we see here with the x squared term, which is again a 1. We don't usually write it, but imagine that there's an imaginary 1 out here. So we would do 1 times the last number here, which is negative 4. So 1 times negative 4 is just negative 4. So now what we want to do is we want to list numbers that will multiply together to give us negative 4, but that will add up to positive 3. All right, so what are some combinations of numbers here that will multiply together to give us negative 4? Well, one would be negative 1 and 4. So if we add these up, if we add negative 1 plus 4, that is going to give us positive 3. So we've already found our pair here. All right, so now what we do is we would just take this bottom portion here in the denominator, and we're just going to rewrite this
now as x minus 1 and x plus 4. All right, so look how quickly we factored that. So this simplifies things down quite a bit, all right? And so now we've got the numerator and the denominator. We've taken two quadratic equations and factored them, all right? But we're not even close to being done yet. So we still need to find that domain. So again, what we want to do is we want to take the whole bottom portion of the fraction now and set these equal to 0. So we want to take this x minus 1, set that equal to 0, and then we're going to take x plus 4 and set these both equal to 0 here. All right, so let's do that. So let's try x minus 1 first. So let's set that equal to 0. So if we do x minus 1 and we set that equal to 0 and solve for x just like you would for an algebra question, right? So we want to get x by itself here. We want to isolate this x. So since it's x minus 1, we do the opposite of minus, which is plus. So we then also have to add 1 to the other side. So we would see that x equals 1, okay? And so now let's do the same with this x plus 4. So we take our x plus 4, and we want to set that equal to 0 as well. So we do our x plus 4, okay? And again, we're setting that equal to 0, and we want to get the x by itself on the left-hand side of the equation. So since we've got this plus 4 here, we do the opposite of addition, which is subtraction. And whatever you do to one side, you also do it to the other. So we're then left with x equals negative 4. All right, x equals negative 4. So when x is equal to 1 or when x is equal to negative 4, well, the function is going to be undefined. So let me just show you with an example of what I mean here. So let's just say that the top part of the fraction, I'm just going to call everything in the top part a, just to prove a point here, all right? So let's say that the x is equal to 1, okay? So we're going to leave the denominator the same here, all right? And I'm just going to plug a 1 in for x here. So I'm going to plug a 1 in for both of the x's down here. And I just left the top part as a because I'm just proving a point here. So if we substitute a 1 in for x, we would have 1 minus 1, and then we would have 1 plus 4. Okay, so 1 plus 4 is going to be 5, but here's the problem. All right, 1 minus 1 is going to be 0. So if I rewrite this, we were going to have 0 times 1 plus 4, which is 5. So we have 0 times 5. 0 times 5 is just 0, so we would end up with a divided by 0. And we're going to get a divide by 0 error here because you can't divide by 0. So that's why we know the function is undefined where x equals 1. All right, and so now let me clear this out of the way here. And I'm not going to walk through this for the sake of time with negative 4, but the same thing would happen if I plug in negative 4 for x. All right, so let's say I take this negative 4, plug it in here for x, all right, negative 4 plus positive 4 is going to give us 0 here, all right? And so just because we have that 0 here, 0 times this over here is going to make the whole denominator equal to 0, and therefore you can't do the problem anymore because you're going to get a divide by 0 error in your calculator because you can't divide by 0, all right? So we know that the domain is going to be all real numbers except for x equals 1 and x equals negative 4, all right? So that's how you would get the domain, but what about the range, all right? So again, the domain is going to be all numbers except where x equals negative 4 and x equals 1. So remember that the range is just all of the outputs, all right? So the range is all the possible outputs. So we know that all inputs will work. We can put in any number here except for 1 or negative 4 for x, okay? But what about the outputs? So here's kind of a concept here that I want to clear some room out of the road here because this is very, very important to understand here. Okay, and this is semi-complicated, but you guys are really smart, so you can get this. So what we see here, if we go back to the original part of the problem here where I took the two quadratic equations and I factored them. So we see that we've got x plus 4 and x plus 4. So we can actually, since we've got an x plus 4 up here in our numerator and an x plus 4 down here in our denominator, we can actually cancel these out. Okay, and so when we cancel these out, we can rewrite our function. Okay, so we can rewrite f of x as equal to x plus 4 divided by x minus 1, okay? And this is really where the magic happens, okay? So since we've got x minus 1 down here and we've got x plus 4 up here, all right, no matter what happens, so no matter what x is, right, can't you see that the numerator and the denominator, they're never going to be 1. We're never going to get an even ratio. So if we've got any number up top and if we've got that same exact number in the bottom of the fraction, okay, the fraction is just going to be equal to 1 because anything divided by itself is going to be 1. All right, but no matter what we put in for x here, we're never going to be able to get that, all right? So for example, let's say we plug in 2 for x, all right? So if we plug in 2 for x, we would have 2 plus 4 okay, up top, and then down here, we're going to have 2 minus 1, okay? And so this is obviously going to be equal to 6 divided by 1, which is 6 over 1, okay? So no matter what happens, this can never be 1, all right? And the reason is because of the way we see that x plus 4 in the top and x minus 1 in the bottom. So what you have to understand here is that the range is going to be all real numbers, so you can get any possible output here except 1. This function will never be equal to 1. Okay, so question 3, solve the equation for x without using a calculator. So we see x squared equals 50. Find what x is equal to without using a calculator. Pause the video and try to do that now. Okay, let's go over how to do this. So first of all, I want to point out a very common mistake here. So what some students might do is they might think that, well, I want to get x squared, so x squared is equal to 50 squared. And 50 squared, to get that, I just do 50 times 50. And this is actually incorrect. That's not how you would find x here in this situation. So if you did this, that's okay. Give yourself a pat on the back for trying, all right? I admire your effort, but this is actually the wrong approach. All right, so let me cross this out so we know that this is the wrong approach. And this is a common question I get from GED test takers. So you're definitely going to want to understand this concept here because it's very important. Because I get this question a lot by people who are confused about this. They think x squared equal to some number. They think they just square that number, and that's actually incorrect. So we want to find this x, all right? So we want to solve the equation for x, but right now we see that we have x squared, all right? So we don't want to solve the equation for x squared. It's already solved for x squared. We want to solve for x. So the important thing to understand here is that if you take the square root of any number that's squared, it's just going to give you that number, all right? So for example, all right, the square root of x squared is just equal to x. It doesn't matter what number you put under here. You could put in 80, doesn't matter, pick any random number and square that number. So 80 squared, what's the square root of 80 squared? It's just 80, all right? Again, you could put in any number, literally, you could do 20, 22. Let's say we've got 22 squared. The square root of 22 squared just gives us that 22, okay? So that's the idea here, all right? We've got this x squared, and if we take the square root of x squared, it's just going to give us x. All right, but whatever we do to one side of an equation, we also have to do it to the other. So we're also going to have to take the square root of 50. And we're going to have to find out what the square root of 50 is without using a calculator. All right, so that's the strategy here. And so how are we going to do that? Well, in order to do that, you want to know these, what I call common square roots, all right? And this is a good list to put down in your notes and review it every couple days or so, or memorize it. You can use flashcards, however you want to do it, but you definitely want to know this if you want to score well on the GED. So some common square roots, so I'm not going to read the whole list here, but you're more than welcome to pause the video and study these more in depth here. But you've got the square root of 1 is just 1, the square root of 4 is 2, square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, and so on and so forth. But these are all good numbers that you want to have memorized. So the strategy here is we're going to take 50 and we're going to break it down into two numbers that will multiply together to give us 50. Okay, and so we want to find pairs of numbers that will multiply together to give us 50. And we want to find a pair in which one number in that pair, okay, is one of the numbers I have written here underneath the square root symbols. All right, so for example, we want to find a number that's either a 4 or a 9 or a 16 or a 25, something that has a common square root. All right, and this will make more sense when I show you the example. So to get started, we want to list factors of 50, all right, factors of 50. So in other words, two numbers that will multiply together to give us 50. All right, so let's just list pairs here. All right, so what about, first of all, the obvious one would be 50 and 1. All right, now there's also 5 and 10. So somebody might be thinking, well, I thought you said we want to find numbers that appear on the left-hand side of the list here, right? In other words, numbers that have a square root that's a common number. All right, well, we do, but the 1's not going to help us out here. So 50 and 1, you might say, well, the square root of 1 is just 1, so that doesn't help us, but good thought process if you were thinking that. So here's another pair. What about 2 and 25? Well, this actually hits us right, it hits the bullseye because we see that the square root of 25 is 5, all right? So see how I did that again. To find the square root of 50, I just started by thinking of pairs of numbers that will multiply together to give us 50. And we found 2 and 25, and we see that we wanted to find a pair that had one of the numbers that has a common square root. So in other words, one number in the pair, we want it to appear underneath the square root symbol on our list of common square roots. And we see that 2 and 25 will do the trick because 25 has a common square root. All right, in other words, the square root of 25 gives us a common number, which is 5. All right, and so now what we're going to do is we're going to take the square root of 50. Okay, and now let's rewrite this. Okay, so the square root of 50 is equal to the square root of 25 times 2, and this little dot means multiplication. So the square root of 50 is equal to the square root of 25 times 2. Okay, so now we can go even further here, right? Because we know the square root of 25. It's a common number. It's a 5. It's not going to give us some weird decimal or some weird number like the square root of 2 would be. All right, so we know the square root of 25. So the square root of 25 is 5. So I'm just going to rewrite this out here as 5, and I'm going to leave the 2 under the square root. All right, and so the answer here is that x equals 5 square root 2. Okay? 4. What is the equation of a line that passes through the points -2, -1, and 16, 4? Go ahead and pause the video and try to figure this out. So I've written 3 equations up here, and I don't want you to be intimidated because we're going to explain what these mean, and it's really not that complicated once we break it down. So first of all, let me draw your attention to this equation right here, y equals mx plus b. So y equals mx plus b, this is the equation of a straight line. All right, and what this means, this little m represents the slope. So the m symbol, it just represents the slope of a line. Okay, and the b is our y-intercept. Okay, so the y-intercept is on a graph where the line crosses the y-axis. So let me just break this down quickly here. So this is just an example of a graph, okay? And so the line that goes up and down here is what we call the y-intercept. And the line that goes left and right here, or horizontal, is our x-intercept. So here's our x, or it's not the x-intercept, the x-axis, I should say. So the line going up and down, again, is the y-axis, and the line going left and right is our x-axis, all right? And so let's say we've got an equation of a line here, right? We've got a line that goes and passes, all right, across the graph. So right here at this point, okay, where we see that the line crosses the y-axis. Remember, the y-axis goes up and down. So where the line crosses the y-axis, we call that the y-intercept. Okay, and where the line crosses the x-axis, we would call that the x-intercept. Okay, so now we see that we've got a line here, and whenever you've got a line, you can find the equation of that line if you know the slope and 2 points that are on that line here. So for example, this -2 and -1, these would be 2 points on a line. Same with the 16 and 4, okay? So another thing that you want to know here about slope is the general concept, okay? So let's say that, imagine that you are going to run down a big hill, okay? Now I'm sure you're much better looking than the stick figure, but you get the point here. So let's say that this is a hill that you want to run down. All right, which hill would you run down faster? Okay, a hill like this, or let's say a hill that looks like this, okay? So obviously, if you were going to run down a hill, all right, the hill that is steeper is you're going to go down it faster, right? So imagine if I gave you something like this, okay, a hill that looks like this, that's practically straight up and down. Okay, you're going to run down it so fast because it's so steep, right? But, you know, this hill here, this looks like it's going to take you longer to run down because it's not nearly as steep. All right, so that's what the concept of slope is. It's just a number that tells us something about the steepness of a line. So the slope, you can think of the concept as it just gives us a snapshot of the steepness of that line, okay? And so you might also have heard the slope called the rise over the run, and what that means is, remember we said that the y-axis goes up and down, and the x-axis goes left and right. Okay, well what that means is, you know, the rise would be going up here. All right, so we might rise, let's say this is 1, and this is 2. All right, so we might say, hey, you know, on this line we rise up 2, and we could call this 1, this 2, and this 3, for example. 1, 2, 3. All right, so for this line we would say, hey, well, the rise is 2 and the run is 3, and we would write the slope as 2 over 3. So that's another way to think about the slope, as the rise over the run. Okay, so another important thing to understand about lines here, okay, when you see an equation of a line, is there are both positive and negative slopes. So whenever you see a line that goes down, so when you go from left to right, like it starts high and it goes down, a downward line like this, the slope will always be a negative number. Okay, now whenever you've got a slope that going from left to right, it goes up. So it starts low and goes up, that's going to have a positive slope. Okay, so now a line that is horizontal like this, so here's our x-axis, a line that runs like this, just kind of parallel to that x-axis, okay, this line is going to have a slope of 0. Now, if you have a slope, though, that's vertical and that's straight up and down, all right, this is going to be undefined, all right? You can't have a slope in this situation if your line is straight up and down, all right, because we don't see this rise over run, okay? We don't have a rise over run there. Okay, so just some things to keep in mind here. All right, and so also these different numbers, we see that we've got these negative signs here, right? And we've got a positive sign. So what do I mean by this? Well, usually if we were on a graph here, right, the numbers going out here would be positive numbers. Like we would have +1, +2. Now if we go the other way, right, so if we start right at the center of the graph, which right here in the center, okay, we call this the origin because the coordinates are 0 and 0 right here. So there's 0 on the x-axis and 0 on the y-axis. So in a coordinate pair, you always write the x value first and the y value second, okay? So if we go in the left direction, we would see a -1, all right, then -2, and so on and so forth, okay? So the same thing going down, all right? So let me clear that out of the road so we can see a little bit better here, right? So if we're going down, say, for example, the numbers also get negative, right? So if we go down here, this would be, for example, -1 and -2. All right, but if we start at the origin and go up, the numbers get positive. So this could be, for example, +1 and +2 here. Okay, and so here's what we can say about the different quadrants. So we can divide these up into what we call quadrants, right? So we can have a quadrant here, 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 and here. So there's 4 different quadrants. And so over here, okay, we would say all of the x values, okay, will always be negative, okay? And the y's over here are always going to be positive, okay? All right, so any point on a graph that you find up in this quadrant here, the x will be negative and the y will be positive. So over here, we would have positive and positive. So our x value, so any points over here in this quadrant would be positive and positive. All right, so down here, we would have a positive x value but a negative y value. Okay, and so over here, we would have both negative x and negative y. Okay, so just something to keep in mind here, just to give you kind of a snapshot, all right? And so like I said, in any coordinate pair, you always list the negative number for, you always list the x number first and the y number second, okay? So just to give you some context here to what we're doing, but the point here is that this equation here, this y equals mx plus b, this is going to give us the equation of a line, all right? So now that we've got the concept out of the way here, how do we find that? Well, first of all, we're going to use this formula down here. So this is what we call the point slope formula, all right? And so we use this formula, okay, when we know the slope and we have at least one of the coordinate pairs, and this will tell us the equation of the line. So in order to get this y equals mx plus b, okay, as long as you know the slope and as long as you know at least one of the coordinate pairs, right, so one of the pairs of the line, you can use this formula, y minus y1 equals slope times x minus x1, and that's going to give you the equation of the line. Okay, so how do we get the slope? Well, that's what this up here is. This m equals y2 minus y1 divided by x2 minus x1. That is our equation for the slope. Okay, so this all might sound a little bit complicated, but once we break down this example here, it's really not that hard. So first of all, the first thing that I'm going to do here, I'm going to label these coordinate pairs. All right, so let's call this number x1. All right, the first number we'll call x1, and the second number in this pair we'll call y1. All right, and so here we'll call this 16. Okay, let's call the 16, let me rewrite this over here. So we're going to call our 16 is going to be our x2, and our 4 is our y2. So 4 is our y2. All right, so to find the slope, all we're going to do is we're going to take these numbers and substitute them into the formula. So what I mean by that is, so our y2, right, our 4, we substitute that into our equation for y2. All right, and so our y1, again, which is -1, we just substitute that in for our y1. Same with the x's, so we take the value for x1, which is -2, substitute it in here for our x1, and this x2, which is 16, substitute this in here for x2. So I'm going to clear this out of the road here because it's going to get a little bit stuffy on the board, but hopefully you're seeing the point here. So the first step here to find the equation of the line, we need to find the slope. And then once we found our slope, we then use this formula. So first we use m equals y2 minus y1 divided by x2 minus x1 to get the slope. Then we use the formula, the point slope formula, y minus y1 equals slope times x minus x1. Let's go ahead now and calculate our slope here. So we need our y2. So our y2 is 4. And we need to subtract our y1. So our y1 is just -1 here. So we're going to be doing 4 minus -1. So whenever you do minus a -1, minus a negative number, okay, it becomes a plus. So 4 minus -1 is the same as 4 plus 1. Okay, and so now we want to do, or let me make this a little bit smaller, but the next step here is to do x2 minus x1. All right, and so our x2 is 16. and our x1 is negative 2. So again, 16 minus negative 2 is the same as 16 plus 2. So whenever you do minus a negative, it just becomes a plus. And of course, let me put the slope symbol here. All right. So what we've done is, again, we're calculating the slope, and we do y2 minus y1 divided by x2 minus x1. And the reason that these look like these are pluses here is because whenever you subtract a negative number, it becomes a plus. So instead of doing 4 minus negative 1, we would just write that as 4 plus 1. All right, same thing. All right, so now we can calculate the slope. So what's 4 plus 1? That's 5. And what's 16 plus 2? That is 18. So our slope is 5 over 18. All right, so we're on the right track here. We've got 5 over 18 as our slope. All right, so now what we want to do is use this formula here, y minus y1 equals m times x minus x1, and this is going to give us the equation of the line, okay? So let's start off here. So y minus y1. So our y1 is negative 1. So we're just going to fill these numbers in here. Y minus y1. All right, so we do y minus negative 1. So again, any number, okay, minus a negative, you just make that plus. So y minus negative 1, that becomes y plus 1. So that's equal to our slope, okay, which is 5 divided by 18. Okay, so we've got our y minus our y1 is equal to the slope times x, and we're just going to write an x here, minus x1. Okay, so what's our x1? Well, we just look up here and we see that that's negative 2. So again, x minus negative 2, we can just write that as x plus 2. Keep life simple. Okay. So now what are we going to do? Well, we're going to solve our equation here, okay? So there's a couple ways. So the first thing you could do is you could subtract 1 over to the side of the equation, but I'm going to save that step for right now. All right, so what we're going to do here is we're going to distribute this 5 over 18. So first we're going to take the 5 over 18, multiply it by x, then we're going to take the 5 over 18 and multiply it by our 2, okay? So in other words, we are going to distribute it, all right? So let me rewrite this. So we've got y plus 1 is equal to 5 divided by 18. Now it's times x because that does not look like an 8, but pretend that's an 8. So we've got 5 divided by 18 times x plus 5 over 18 times 2. Okay, so what's 5 times 2? 5 times 2 is 10, so we can just write that as 10 divided by 18. Okay, and so we can actually simplify this fraction now, right? So what if we divide both of these by 2? So what is 10 divided by 2? 10 divided by 2 is 5. And what's 18 divided by 2? Well, 18 divided by 2 is 9. Okay, so we can simplify that to 5 over 9. So we now have 5x divided, we have y plus 1 equals 5x divided by 16 plus 5 over 9. And so now what we're going to do is we're going to subtract this 1. All right, so we'll have y equals 5x, hopefully you guys are with me here, 5x divided by 18. If you're with me, then you're doing an excellent job right now. So props to you. Y equals 5x divided by 18, all right, plus 5 over 9 minus 1. Okay, so we're almost done. We can do one more simplification here. So we've got 5 over 9 minus 1. Okay, so what we can do now is we can subtract 1. So 5 over 9 minus 1. Now, you could just do that in your calculator, but I like to keep it as a fraction here. So we know that any number, okay, just written as a number is really that number over 1. So if I pick any random number, like say 99, and I just say, hey, here's a 99. Okay, you can really think of it as 99 over 1, but there's really no reason to write that normally speaking. But in this case, we're going to write it over 1. So we've got 5 over 9, okay, minus 1 over 1. And so we need to get a common denominator here. So we want to do 5 over 9 minus 1 over 1. So to do that, we want to get a common denominator. So the denominator is the bottom number in a fraction, and the top number in the fraction is called the numerator. So to get a common denominator, we want to get the same number in both of our denominators here. So we've got a 9 and we've got a 1. So we've got to multiply the denominator by 9, and whatever you do to the denominator, you're going to do it to the top number as well. So we have to multiply both by 9 here. Okay, so really, we can now rewrite this as y equals 5x divided by 18, and then we're now adding that to 5 over 9 minus 9 over 9. So what is 5 minus 9? Well, actually, we're taking 5 minus 9, so that's going to give us negative 4, right? Because 5 is smaller than 9. So if we do 5 minus 9, that's negative 4. Okay, so basically, what we're going to end up with is our final answer up here. So I'm going to write it big right in the center. We've got y equals 5x divided by 18. And then that's plus, or actually now that's minus. So it's minus, right, 4 over 9. Okay, and so then we're done. Okay, so now the question is find the value of the following number without using the calculator. And we see the fraction 17 over 4. And I've given you multiple choice answers. So go ahead, pause the video, try to figure it out. Is it A, B, C, or D? All right, let's go over this. Hopefully you had a chance to try this one. So the first thing that we have to understand here is that we want to do this without using the calculator. And so we've got to recognize what kind of fraction this is. So this is an example of an improper fraction. Okay, it's an improper fraction. All right, and the reason is because the top number in the fraction is bigger than the bottom number. So the top number in the fraction, again, is called the numerator, and the bottom number is called the denominator. And one way to remember that is to think, hey, the denominator, well, denominator, that sounds like in the dungeon or downstairs. So the denominator is downstairs or in the dungeon. The way I tell people to remember the top number in a fraction is really silly, but I tell them, think of Newman's salad dressing. So if you've ever had Newman's salad dressing, you know that Newman's salad dressing goes on top of the food. The numerator is the top part of the fraction. So it's kind of silly, but hopefully that helps you remember it. All right, so an improper fraction has a numerator that's bigger than the denominator. Again, numerator, top number in the fraction, denominator is the bottom number in the fraction. All right, so now on the other hand, if this looked the other way, right, if this was instead 4 over 17, all right, then we would have a proper fraction. So for a normal, regular, everyday, average proper fraction, okay, the proper word is proper fraction, pun intended, the top number would be smaller than the bottom number for a proper fraction, but that's not what we have here, okay? So we've got to work with this improper fraction, 17 over 4. Now, the good thing about improper fractions is that we can turn them into what's called a mixed number. Okay, and so a mixed number, it's got a whole number and a fraction, okay? And so we're going to look at how to do that now. So we want to turn this mixed number, we want to turn this fraction, 17 over 4, into a mixed number. All right, so that's the goal here. So how do we do that? Well, to turn an improper fraction into a mixed number, okay, the first thing that we have to understand is that we keep the same denominator. So the denominator of the improper fraction and the mixed number are going to be the same. So we keep our 4 in our denominator. So there's going to be a big number that's going to go out here, okay? We're not necessarily a big number, but it's going to look big in comparison to the number down here and the number down here because it's a whole number. So we put a whole number right out front here in the fraction. Then we also put a number in our numerator. So how do we know what goes where? Okay, well, what we want to do is we want to think of a number that we can multiply the denominator by that's going to give us a number that's close to 17, but that's not quite 17. Okay, so let me say that again here. So we want to put some number out here. So I'm just going to put an A for now. Okay, and we want to multiply 4 by that number. Okay, and we want the result to be a number that's close to 17, but not quite 17. It's got to be a little bit smaller than 17. All right, so one way to do this is just guess and check. So let's just go through our 4 times tables quickly. So what's 4 times 3? 4 times 3 is 12. All right, what about 4 times 4? Well, 4 times 4 is what? 16. And now 4 times 5. I'm going to pause to give you a quick quiz here. 4 times 5 is what? 20. All right, and so 5 would be too big because we want a number that's close to 17, but it's not quite 17. So 5 would be too big. But 3 is going to be too small because we can get a little bit closer, all right, with 16. So 4 is going to be the perfect answer here, all right? So instead of an A, we're going to put a 4. So let me drag this whole mess down here. So again, we keep the 4 in the denominator, and we're going to put a 4 out here. So 4 multiplied by 4 is 16. 16 plus 1 is 17, so we put a 1 up here, all right? And so now we've got our mixed number. So you should be able to go from mixed numbers to improper fractions and from improper fractions to mixed numbers fairly simply. So this is a mixed number here. We've got our whole number out front and we've got our fraction here. And so how do we go back to an improper fraction? So the way that you do that is you take the number in the denominator, multiply it by the whole number, and add the number in the numerator. So we would do 4 times 4, which is 16, plus 1 gives us 17, and remember the denominator is the same, all right? So that's a way to check that we've got the mixed number correct here. All right, so again, make sure that you know how to go between an improper fraction and a mixed number fast, and make sure you can do going both ways, from an improper to mixed number to improper fraction, okay? So now we're almost to our answer. So this 4 and 1/4 is really helpful here. So right off the bat, okay, the fact that we've got a 4 out here, that should cue you in that C is the right answer here. But how do we know that it's 0.25? Well, 1/4 really is equal to 0.25, all right? So this is another point that you'll want to know, all right, for the GED, but also for general math, okay? So you want to know some basic decimal values that are going to come up over and over again, okay? So I'm going to write some out here for you. These are really important to add to your notes, okay? Or even better yet, just memorize them. So, okay, so the first thing to understand here is that 0.25 is equal to 1/4. Okay, so we're looking at fraction decimal equivalents here. All right, and 0.50 is equal to 2/4, all right, or half. Okay, and 0.75 is equal to 3/4. Okay, and so now 1, all right, is just equal to 4/4, all right? And so the best way to think about this is to think about quarters, okay? So if you've got 1/4, you've got 25 cents. If you've got 2 quarters, you've got 50 cents. If you've got 3 quarters, you've got 75 cents. If you've got 4 quarters, you've got $1 here, okay? So that's the best way to think about it whenever you see fourths in the bottom, right? So if you see that you've got 4, all right, or you've got 1/4 or 2/4 or 3/4, just think about quarters. Hey, if I had 3 quarters, I'd have 75 cents. So 3/4 is equal to 0.75, all right? And so if you just memorize these values here, all right, you'll see that 4 and 1/4 is the same as 4.25, all right? And so now also a way to do it is you can put these in your calculator anytime here, all right? So if you had been able to use your calculator, you could have really sidestepped all of this. You could have put 17 divided by 4 in your calculator. That would give you the same answer here, all right? But that wasn't the point. The point is I wanted you to take this improper fraction and convert it to a mixed number. Then once you add that mixed number, to see that this 1/4 is equal to 0.25, which is why we got the 4.25 here, all right? So as an add a little bonus to this question, let me give you something else that's really common, all right? So another really common fraction to decimal equivalent is 1/3, all right? So 1/3 is equal to 0.3333, just a bunch of repeating threes, okay? So another way to write that is just 0.33, and I'll put a little sign up here. This little line means repeating. So if you do 1 divided by 3 in your calculator, you're just going to get 0.333 and a bunch of threes that repeat, okay? All right, and so if you do 2 divided by 3, okay, what you're going to get is you're going to get repeating 6s. Okay, you're going to get 6, you're going to get 6, and I'm going to put this repeating symbol here. All right, and so those are 2 other numbers that are important to have memorized here. Okay, so hopefully this all makes sense, and hopefully you got 4.25 and you didn't get D that you had no clue, but if you did, hey, that's okay. At least you're here. At least you didn't give up. Even if you picked D here that you had no clue, that's better than giving up and not picking. So another bonus lesson here is on the GED test, always pick for a multiple choice answer. Don't ever leave a multiple choice question blank. Just guess anything even if you're stuck on it. Question 6 says, if the mean of the following data set is 150, what's the missing number? And we see a data set here with 14, 19, X, 2, and 16. All right, so pause the video and try to find the mean. Okay, let's go over how to do this. So this is another type of question here that it's not really that hard once you see how to do it, but a lot of students don't get the concept until they've been shown how to do it. So let's go through this now. So give yourself a pat on the back again for being here in this video right now, trying to improve your life by passing the GED test. So what I want you to think of here is the mean. So what really is the mean? What do I mean when I say mean? All right, pun 100% intended. So the word mean here is another word for average. So the mean means the average. So whenever you hear the word mean means the average. So whenever you get a question, say on mean, median, mode, and range, you'll know that that mean just means the average, okay? And so in this case, we see that it says if the mean of the following data set is 150, what's the missing number? We should right away think, hey, we see the word mean means the average. So since mean means the average, we would just find the mean the same way that we find the average because they're the same thing. The mean means the average, all right? You're probably getting tired of hearing me say that, but hopefully you're getting it that the mean means the average, all right? And so the way you find the average is you take all the numbers in a number set and you add them up and you divide by the total number of numbers in that data set, all right? So here, let's pretend that we don't know what the mean is because they told us what the mean is. They told us the mean is 150. So let's just pretend that we don't know what it is. So how would we find the average? Well, what we would do is we would take all of our numbers in our number set, right? And we would add them up. So we would do our 14, 19, x, 2, and 16. Then we would divide by the total number of numbers in our number set, all right, or the total number of data points, 2 words for the same thing. So let's count them. We've got 1, 2, 3, 4, 5. All right, so we would divide by 5. And so now basically, all right, we see now the problem becomes evident. So we could not solve for the mean in this situation because we don't know what this x is, okay? We don't know what this missing number is. So this is how you would find the mean if we didn't know the mean and we knew what this x was. Okay, you would add these up and divide by 5, but unfortunately, that's not the case here, all right? So we don't know what the mean is. Or we do know what the mean is. We don't know what that x is. So we fortunately do know what the mean is, all right? The mean is 150, all right? And so we can put 150 in there, and now hopefully it becomes obvious to you that we have to solve for this x. So the way we're going to do this is just using basic algebra. We're gonna pull out our wheeling and dealing skills as far as dealing with solving equations here, and we're going to solve the equation for x. So when I say solve the equation for x, we want to basically get this x by itself on one side of the equation here, all right? So hopefully you've been taught what PEMDAS is before. If not, then today's the day that you're going to learn, all right? So PEMDAS, please excuse my dear Aunt Sally. So the P stands for parentheses, and the E stands for exponents and square roots. The M stands for multiplication. The D stands for division. The A is for addition, and the S is for subtraction. So this is your order of operations. So when you've got equations to solve, all right, you want to solve them using this order of operations, meaning you would do what's in the parentheses first, all right, you would do what's has exponents or square roots second, you would then multiply, you would then divide, and the order of addition and subtraction is fairly arbitrary. You could subtract before you add. It's not going to change the answer, but we usually just say AS first because PEMDAS sounds better than PEMDA-SA, whatever that would mean, right? But anyway, I mean, I usually do addition before subtraction just because I remember it that way, but that's not that important. But what is important is doing your multiplication and division before you move on to addition and subtraction, and making sure you start with what's in the parentheses, and making sure that you do the exponents and square roots before you jump into your multiplication, division, and addition, subtraction, etc., etc. All right, so I have a video on PEMDAS if this is a foreign concept to you, but I'm going to explain what you need to know here. So there's one more caveat to this, all right? So whenever you've got a division bar here, all right, you treat the division bar like a parentheses. And you might be thinking, what does that mean? Why would I treat the division bar like a parentheses? Okay, well, I'm going to show you how. So you would treat this, since you've got this division bar here, as if there's parentheses around the top number and parentheses around, or the top, not the number, the top part, everything in the top part of the fraction here. So all of these numbers here, and you would treat it like there's parentheses around the bottom number too. All right, and so now that we have this division bar, we know we've got to treat the division bar like parentheses. So now we would then, following our PEMDAS rules, we would do everything in the parentheses first before we move on to the rest of the question. And so this is one caveat to PEMDAS that a lot of people don't understand, is that P is for parentheses, but you treat a division bar like parentheses. So basically what we're going to do here is we're going to simplify everything up here. So we would do 14 plus 19 plus 2 plus 16. All right, and if you do that in your calculator, you'll find that that equals 51. So let's bring this all down here. Sometimes I can't talk right, but hopefully I can talk right for the rest of this question. So we've got 150 equals 51 plus x divided by 5. So hopefully you guys are really smart, so I'm sure you're following. But if you weren't able to follow that, all I did was I did 14 plus 19 plus 2 plus 16 in my calculator. That was equal to 51, and we still have plus x here. All right, and so we're dividing by 5. All right, so now remember, this division bar means that you've got to treat everything in the top and everything in the bottom like it's surrounded by parentheses. So we would, in theory, simplify what's going on up top in the fraction and simplify what's going on in the bottom first. But since we've already done that, we can't add 51 to x because we don't know what x is. Then we're good. We'll leave the top as it is. And we now want to multiply both sides of our equation by 5. So why do we multiply both sides by 5? Well, because we see that we've got 51 plus x divided by 5. We want to get x by itself, all right, and we can't do anything with the 51. We can't subtract the 51, all right. We can't do that right now because we've got to deal with this 5 first down here, all right? So we can't do any more simplifications, all right? So now we can't add 51 to x, and we've done everything in the parentheses that we can. So now we will move on to multiplication and division, all right? And so now we multiply by 5 on both sides of the equation, because whatever you do to one side, you do to the other. So since we've got 51 plus x divided by 5, we multiply by 5. 5 divided by 5 is just 1, so we'd have 51 plus x times 1. Who cares about the 1? Okay, so 5 times 150 is 750. So now what we have is 750 is equal to 51 plus x. And so now, since we want to get x by itself, we see 51 plus x, so we want to subtract 51 from both sides of our equation, all right? And so 750 minus 51 is going to give us 699. Sorry for that dramatic pause, my calculator was lagging, and that's the reason. But 699 is x, so the value of x, the missing number, was 699 all along. Did you get this right? Let me know in the comments if you did. So right now, as you sit there listening to this, you might be wondering, why does this question say 121? Well, the reason is because I pulled this one directly out of my book, The GED Math Champions Guide, the Champions Guide to Winning on the GED Test Math section. So if you're interested in that and you like these hard problems, definitely check out that book. I've got a link to it down below if you want to look at it. But anyway, that's why the number says 121. So this is a very challenging problem, and this is really going to test your understanding of geometry. So let me just add one note in here. This is a right triangle. So it says the following figure consists of a square, a triangle, and a rectangle. What is the perimeter and area of the figure below? Both rounded to the nearest whole number. All right, pause the video and let's see if you can get this. Okay, let's go over this. So first of all, this problem is asking you to find two things, the perimeter and the area. So we don't want to just find one. So let me put a P here for perimeter, all right? Because at the end, we're going to make sure we found both. So whenever you've got a multifaceted question like this, you want to make sure you do both things. And then this A obviously is for area. So at the end, we'll make sure that we found both here. All right, so to break this down, we see that it says the figure consists of a square, a triangle, and a rectangle. All right, so first let's identify the square, triangle, and rectangle. So hopefully, all right, you see here that we've got the square right here. So a square is a four-sided plane figure. It's got a 90-degree angle in each of the corners here. So this little box type thing just represents a 90-degree angle. Why is it a 90-degree angle? Well, let's say that you've got two lines like this and they intersect and form a 90-degree angle. We call these lines perpendicular lines. So perpendicular lines intersect and create this 90-degree angle, which looks like a little box type thing. All right, so that is a 90-degree angle. And anyway, in each of the four corners of a square and for a rectangle, we're going to see these little box type things. All right, and so the right triangle here, so this is our triangle. Okay, I'm tracing our triangle here, and it has this little box type thing in the corner, which means that that is our 90-degree angle here. Okay, so the good thing about squares that you need to know is that all sides are the same length. So every side of the square is the same length. So if this is inches, meters, we don't really know. It doesn't really matter, but we know that for a square, each side is going to be a length 10. Okay, and so with the rectangle, all right, the opposite sides are the same length. So let's say we've got 11 here, all right, and so for the rectangle, we would call this 11 as well, and this side over here would be 32 as well. All right, so for a rectangle, you've got sides that are opposite and they're the same length. So just by seeing this 32 here, we know that this side is also 32, and by seeing that this side here is 11, we know that this side is 11 too. So the good news is that for our triangle, we know two sides for the triangle. So we know that this line here for the triangle is also going to be length 10. So that this side of the square is also the side of the triangle, so they're both 10. And down here, we see that our rectangle, all right, shares a side with the triangle. So for the rectangle, this side is length 11, and same with the triangle. This side is going to be length 11 for our triangle. So the only side that we don't know is this big line right here in our triangle. All right, so we don't know the length of this line. All right, and this line on the triangle is called the hypotenuse. So the hypotenuse is the side of the triangle that's directly across from or opposite from our right angle, which is this little box type thing. So the 90-degree angle is across from our hypotenuse. All right, the hypotenuse, again, is the biggest side of that triangle, and I'll explain why that is in just a second. So in order to find the perimeter, we just have to add up the sides, all right? We just have to add up the length of each side here, all right? Now to find the area is going to be a little bit trickier. All right, so for the perimeter, we just have to add up all of these sides. But the thing is that we don't know what the side of this triangle is. So the hypotenuse of the triangle, we don't know what that is. So how can we find that? Well, let me just pull this triangle out here, and we'll look at this more in depth here, because this is extremely important to know for your test, all right? So as you listen to this right now, all right, first of all, give yourself a huge, big round of applause for being right here with me right now, working towards your GED. Good for you, and also for sticking it through the video. You don't want to be a quitter. You want to be a champion, all right? And I want to help you get through the GED. So we've got side 10 and we've got side 11 here, and obviously we need to find this side over here. All right, so this is really a Pythagorean theorem question, and this is something you definitely need to know for the GED test. All right, so let me call this side A, and let me call this side B. So whenever we've got a right triangle is a triangle where we've got this right angle, which again, the little box type thing is a right angle. Okay, we can use the following equation, which is called the Pythagorean theorem. All right, so a squared plus b squared, all right, a squared plus b squared equals c squared. All right, so it's just that simple. A squared plus b squared equals c squared. Okay, and so we can use this relationship here to help us find side C. So since this is side A, all right, so side A of the triangle is going to be 10 in this case, all right, and our side B is going to be 11. So we can use this Pythagorean theorem relationship in order to find what the hypotenuse, or the missing side, or side C, whatever you want to call it, is. All right, so we've got a squared plus b squared equals c squared. So we've got 10 squared, all right, plus 11 squared, and that's going to equal c squared. All right, so there's so much stuff here in this question that is just really helpful to understand for your GED. So you're getting so much bang for your buck with this question because there's more than just one little idea being expressed here. There's a ton of ideas. So 10 squared is 100, and hopefully you remember that 10 squared is the same as 10 times 10. Same with 11. So 11 squared is just 11 times 11. All right. So we've got 100 plus 11 times 11, which is 121. All right, so we've got 100 plus 121 equals c squared. Okay, so now we would then have to do 100 plus 121, and that's going to be 221. So we now see 221, and that is equal to c squared. So now what we have to do is we've got to find the square root of c squared. And so this situation right here, this 2 to 1 equals c squared. I love that this came up in this question here because remember earlier on in the video we had that square root question, right, where I told you that whenever you see a number equal to a variable squared, a variable is just another term for an unknown, that we solved that by taking the square root of both sides. So we want to just get c. We don't want c squared. All right, we just need to get this c. So we've got c squared. How do we get just c? Well, we take the square root of that, and in order to do that, we've got to take the square root of the other side as well. So let me just figure out what this is real quick. So we've got 221, and we want to do the square root. I'm putting this in my calculator. Square root of 221, and that gives us 14.867, let's say. So let's say that c is equal to 14.867, okay? And so you know what, we can round that up to, let's just round that up to 15 just to make life nice and simple. All right, so to make life easy, we're just going to say that side C is equal to 15. So we don't need this question mark here anymore, all right? The question is solved. This side is equal to 15. All right, so hopefully you see how I got all this so far. All right, so if you want to take any notes, now would be a good time to pause the video, all right, because I'm going to clear some space out here so we've got some room to work. Okay, so I hope you got that stuff in your notes if you wanted to. If not, then you can rewind the video and make sure that you get that because that's all important. But I want to touch on another really, really important part of the question here. All right, so you need to understand this Pythagorean theorem because on your test you might get a word problem where they say, hey, it's a ladder. Like you might have a ladder leaning up against the wall where this could be your wall. This side could be the wall, and this could be your ground or your floor, whatever they call it. So this side would be your ground. This is supposed to be a G. And this whole thing up here could be your ladder, right? So they could say, hey, there's a ladder leaning against a wall, and here's the ground, and they might tell you that, hey, there's a 90-degree angle formed between the wall and the ground, and you might have to either find the length of the ladder or find the length of the wall or the ground or something like that. It could also be a pole, it could also be a tree. Doesn't matter, but there's different kinds of word problems they can give you with this. So you just have to remember that this 90-degree angle, right, this little box type thing, all right, that tells you that you can use the Pythagorean theorem relationship, which is a squared plus b squared equals c squared. Now, another common question I get is c always going to be the largest side? And the answer is yes, it has to be. So it doesn't matter what numbers you put in here for a or b. C is always going to be another number because whenever you take a number and you add another number to it, you're always going to get something bigger. Okay, so like, if A is 2 and B is 4, 2 plus 4 is 6, you get a bigger number. All right, now the thing is, this is always going to be true, even if we've got negative numbers, because these are both squares. So even if we do, say, for example, negative 2 squared, and we add that to, say, -1 squared, all right? So even if A is -2 and B is -1, since they're both squared, all right, we're still going to end up with positive numbers. So -2 squared is still 4, right? Because -2 squared is the same as -2 times -2. A negative times a negative gives a positive. All right, same with -1. So -1 squared is the same as doing -1 times -1. A negative times a negative gives you a positive number. So you would end up with 4 plus 1, which is 5, right? So C squared would be 5 in this case. But the point I want to make is that C always has to be bigger. So C is always going to be the biggest side in the triangle. All right, and that's because you've got A squared plus B squared. So whatever numbers you plug in for A and whatever number you plug in for B, you're always going to get, you're always going to get a positive because you're just going to have to square that number. So C is always going to be the biggest side of the triangle. All right, so now let's get back to our original question. All right, now that we found that this was 15, now how do we actually calculate the perimeter? Well, it's actually very simple. We want to take all these numbers on the outside, which I've underlined, and we're just going to add them up. So we take all of the numbers on the outside of the shape and we add them up here. So let me just do the quick method here to write this out here. So we would do 10, starting with this 10 down here. Let's do 10 plus another 10 plus another 10 plus 15 plus 32 plus 11 plus another 32. And what does this equal? Well, if you do it in your calculator, you find that that equals 120. All right, and I did that in my calculator before I did this part of the question. So the perimeter is 120. So again, how do we get the perimeter of this wicked shape here? Well, we just look at each number on the outside, right? So we don't care about these numbers on the inside, just the numbers on the outside, all right? And we add these all up and we get 120. All right, so that's our perimeter, but what about the area? So the area is a little bit different. The area is a little bit trickier here. So basically, we want to get the area of the entire shape. So let's call this A, and I'm going to put a little t here, all right? So the total area, T stands for total, is equal to your area of the square plus the area of the rectangle plus the area of our triangle here. All right, so the area of the square, A little s, the little s stands for square, the little r here stands for area of the rectangle, and A little t, the t stands for area of the triangle. And let me call this little tr for triangle because we already got this AT out here, and this AT out here just is for the total. So basically, we find the area of the square, the area of the rectangle, and the area of the triangle. So now, how are we going to do that though? So let's talk about the area of the square. So the area of the square is equal to side times side. So let's say the area of the square is equal to a squared, or we could say a times a. So let's call any side of the square, okay, let's just call it length a because every side of the square is the same length. So we could say a squared or a times a is going to give us the area of the square. All right, so to do that calculation, we would just do 10 times 10, and 10 times 10 is 100. All right, so you can either do that in your calculator, you can do it by hand, or you can just say, hey, we're multiplying by 10 here. We've got these 2 zeros, so the answer is going to have two zeros, however you want to think about it. All right, or just remember that 10 times 10 is 100. That's good to memorize that times table. So now let's talk about the area of that rectangle, or our AR. And so for the area of the rectangle, okay, the formula is just one side of the rectangle times another side of the rectangle. So length of the rectangle times width of the rectangle, however you want to think about it. I just like to think about it as side times side. So 32 could be side A, for example, and 11 could be side B. It doesn't matter how you label it, you're just doing side times side. So here we've got 32 times 11. All right, so here's a little trick for multiplying by 11s. Ready for this? So as a bonus, because you made it this far into the video, I'm going to teach you a little trick here. So to multiply any two-digit number by 11, just focus on these two digits. So we've got 3 and we've got 2, so we're going to split them up. So we're going to write a 3 here, we're going to put a little space, and we're going to write a 2 here. Now we're going to add them up. So now let's do 3 plus 2. That's going to give us 5. All right, so 3, 52. So that's a quick trick to multiply two-digit numbers by 11. That's your little bonus for sticking with the video so far. All right, so now what about the triangle? So the area of the triangle, or our ATR, is equal to half times side A times side B. Okay, another way to write that is just A times B divided by 2. So half times AB is the same as just saying A times B divided by 2. So the area of a triangle is the side A times side B. Divide them by 2. All right, so let's do that here. Let me write the workout here so we've got a little bit more room to work here. So side A would be 10, side B is 11. So we've got, oh, perfect, we can use our little trick here. So let me draw this line here as a divider. So what we're doing here is side A of the triangle times side B of the triangle. Then we're going to have to remember to multiply by 2. So we've got 10 times 11. So let's use that little trick I taught you. Actually, this is actually, you almost don't even need to, but let's just say you wanted to. So we're going to take the 2-digit number, we're multiplying by 11. We take 1 and we take 0 and we put a space in between. We're going to split them up. We've got 1 and we've got a gap here. We've got a 0. So now we add this up. What's 1 plus 0? That is just 1. So we've got 110 is the answer to 10 times 11. Now, again, since you're multiplying by a 10, you could just put, and there's 1 0 here, you could just think, hey, put a 0 on the end there. And without using your calculator, you would just remember, hey, we've got 11. Let me just put a 0 there, and you could have gotten it 110 that way, or you could do the 11's multiplying trick. Doesn't really matter, all right? But either way, we have to divide this by 2. And the answer is, of course, 55. And I didn't do that in my head. I just did it in the calculator before I filmed this portion of the video, but we know that our perimeter is 120 and our area is 55. Now, if you got this right without any work, let me know down in the comment section because I really think that you're going to pass. I'd be shocked if you got this right without my help. And if you got both the perimeter and the area by yourself and you don't pass the GED test, I'd be shocked, honestly.